Okay, we'll wait for a few more minutes and we'll start. Okay. Let's start. Okay, so we'll start with the new topic, that is your network topology. This is black, so take a different color. Okay. Okay. So we'll see the network topology. This is also a important segment. Okay, though it comes very lesser marks, but it's very essential part. Okay, you could get a lot of things from this segment. Okay. Okay, so we'll see first what is a network topology. Okay, now, so the introduction part. Okay, when all the elements in a network are replaced by lines with circles or dots at both ends, okay, configuration is called a graph of a network. So any uh, electrical network can be converted to the graph of the network. So it is used to solve electrical networks. Okay, this and topology is used to solve the electrical networks. Okay, the important terminology. Okay, that is used in this network graph, and that is very essential to have that segment to know what is the. Okay, we'll see that part. First is your this path. What is a path? Path is nothing. Is a sequence of branches. Okay, traversed in going from one node to the another is called a path. So let's take. I'm giving you a small network. Okay, let's take this as your electrical network. Okay, this is a network, and if I want to convert this in an electrical part, okay, this would be in, I think so, this manner. Okay. Okay, let me convert that. Okay. Okay. Let's take this is your okay. So this is your one node. This is your one node. Okay. So this is your path. Okay. A sequence of branches traversed in going from one node to the another node. Okay. This is your path. This is your path. This is your path. To if we see to traveling from this path, so this is entirely a path. This is a path. This is a path. Going from one. We consider that. Fine. Now, what is node? A node. What is a node? A node is defined as an endpoint of a line segment, okay, and exit at junction between two branches or at the end of an isolated branch. Okay, so if we talk about node, okay, this is a node, this is a node, this is a node, this is a node. Okay, all are the nodes. Okay, that's why it is written a node point is defined as the end point of a line segment. Okay, end point of a line segment. If this is a line segment, so end point. Okay, this is a line, so this is your end point of a line segment, and exits at the junction between two branches. Okay, this is your branch one, this is your branch two, and this is your junction. Okay, this is one branch, this is a third branch, and this is one junction. Okay, this is third branch, this is a fourth branch, and this is a junction. Okay, or at the end of a isolated branch. Okay, now see, this is an isolated branch. Okay, this is your isolated. This is your isolated branch, so that comes under this. Okay. Okay. Now, the degree of node. So it is a number of branches incident to it. Okay. So if a network is there, okay, so this is your node and the incident. Okay, this is your node and this is. So let's draw one. Draw the same part. Okay. Now see over here, which is incident. So my part was like this. It's not working. Okay, this is this. Okay, this is your this. Okay, so what will be the degree of this particular node? Would be 2. If we consider this, okay, this is incoming. Okay, no, we'll consider this. Okay, this is outgoing, this is outgoing, and this, what will be the degree of node of this? It will be 3. Okay, like this, right? So what is a tree? Okay, tree is what is tree? Tree is, it is the interconnected open set of branches, okay, which include all the nodes of a given graph. Okay, in the tree, the graph, there can't be any closed loop. Okay, there is a two thing that is mandatory for a tree. Okay, to getting a tree idea, okay, the idea of a tree. Okay, and the very first thing is it is an interconnected open set. Okay, this is the major thing we have to remember. It's an interconnected open set of branches, okay, which include all the nodes, okay, which include all the nodes of a given graph. Okay, in a tree, the graph, okay, there can't be any closed loop. Okay, so we'll take the same. Okay, this was the graph. Okay, so in this you have to consider everything. So it's over here 1 2 3 4, we have 4 nodes over here. Okay, so what will be the tree of this? Okay, it should be the interconnected open set. Okay, so all nodes will be present over there, so we'll form this. Okay, where 1 is there, 2 is there, 3 is there, and 4 is there, right? So this part is satisfied. The interconnected open set of branches, open set of branches, okay, which include all the nodes. So all 4 nodes are covered. Okay, in a tree there can't be any closed loop. So see, there is no closed loop. Okay, so this is a tree. So what is tree? Tree branch. That is also called as a twig. Okay, this tree branch or twig, okay, it is a branch of a tree. Excuse me. Okay, it is a branch of a tree. And it is a branch of a tree. It is also named as twig. Okay, it is a branch of a tree. It is also known as a twig. One of the, when there is a, we have drawn tree like this, we got this tree. So this is your tree, twig. Okay, tree branches. Okay, tree branches. Tree link or cord. Okay, so it is the branch of a graph that does not belong to the particular tree. Okay, this, what is a tree link? Okay, tree link or cord. Okay, it is a branch of a graph that does not belong to the particular tree. Okay, so let's see. Right, this was our original graph. Okay, and this is was our tree, right? 1 2 3 4, 1 2 3 4, right? So we'll also name as A B C D E F, right? So we'll write B C E. So what will be the tree link or code? Okay, the tree link or code would be your A D, and F. Okay, based on this, okay, this A, D, and F would be your tree link or chord. Next is your loop. Okay, this is a close counter sector selected in the graph. Okay, this is a close contour selected in a graph, right? Now, another is your cut set. Okay, it is the set of element or branches of the graph that separate two parts of a network. Okay, if any branch of the cut set is not removed, okay, the network remains connected, right? Now, the term cut set is divided or is derived from the property designated by the way which the network can be divided into the parts. So what is loop? First of all, loop is a close counter selected in the contour selected in the graph. And what is your cut set? Okay, it is the set of elements. Okay, so what is a cut set? It is a set of element. Okay, it is a set of element or branches of a conductor that separated two parts of network. Okay, if any branch of the cut set is not removed, okay, if any branch of the cut set is not removed, the network remains connected. Okay, the term cut set is derived from the property designated by the way which the network can be divided into two parts. Okay, which the network can be divided into two. Okay, this is your cut set. So so okay, in this graph theory or network, okay, in this network topology, let me change this and draw in another part. Okay, so in cut set, okay, or graph theory and topology, okay, we see two things, okay, cut set and cut vertex of graph. Okay, cut set and cut graph. Now, so whether it is possible, okay, to transfer the graph from one vertex, okay, to the another is determined by how a graph is connected. Okay, it's totally dependent on the how the graph is connected. Now, connectivity is a basic concept of graph theory. Okay, the connectivity defines whether the graph is connected or disconnected. Okay, so what we'll talk about the connectivity. A connectivity is nothing but a graph is said to be connected if there is a path between every pair of vertex. Okay, from every vertex to vertex you could call as a node. Okay, vertex you could call as a node. Okay, vertex you could call that as a node. A graph generally is said to be connected if there is a path between every pair of vertex. Okay, there is a path between every pair of vertex. So this. Okay, path will be every pair of vertex. Okay. So from every vertex, okay, to any another vertex or node, okay, there should be some path to transverse. Okay, that is called connectivity of a graph. A graph with multiple disconnected vertices and edges is said to be disconnected. Okay, so we'll see. We'll see about cut vertex. We'll see first the we'll talk about the cut vertex. Okay, so let's take a graph. Okay, let's take a graph. Any graph as we um, okay. So what we'll do is let's assume. Okay, let G be a connected graph. Okay, G be a connected graph where a vertex, or you will understand with a node. Okay, a vertex, not a. We'll give another name. Okay, vertex V. Okay, which is a part of a G, okay, is called a cut vertex, okay, of graph G. Okay. If now there is a G and V, okay, this is a path, okay, this is a path that is a G, okay, is deleted, okay, if it is deleted from delete V from G, okay, we delete from G, so what will be called that connected graph would be result as disconnected graph. Okay, which result as a disconnected graph. Now, so removing a cut vertex, okay, from a graph breaks into two or more graphs. Okay, so one would be this part, and this would be. So let me draw. Give an example. Okay, this is a graph. Okay, so on removing this DE segment, okay, if we remove a DE segment from this, okay, so what will have, this would be a two individual connected graph, but it will be entirely one disconnected graph. Okay, it will be okay. Now, so in this following, draw this over here. Okay, so in the following graph, okay, there vertex D and E are the cut vertices. Okay, are the cut vertices. Okay, this your D and E are the cut vertices. Okay, now by removing this D and E, okay, okay, by removing this D and E, the graph will become a in disconnected graph. Okay, the entirely graph would be like yeah disconnected graph. Okay, fine. So if we remove this part, okay, fine, this part. Now another segment is we are removing that particular segment. Okay, we are removing D and E. Now if we remove or, okay, instead of that entire line, okay, no, not line, sorry. Okay, now over here Okay, this your D and E are the cut vertices. Okay, means the cut node. So by removing any of this, okay, by removing D or E, okay, the graph would be changed. Okay, the graph would be entirely changed into two disconnected. We'll see how. So let's remove your E. I'm erasing E. E was erased. The vertex is erased. Means this particular vertex is erased. So all its connected part will be erased. Okay, so we erase that part, this part, but this would be removed. Okay, it will be looking like this. Okay, where F, G, N, H could be there. So now we could see clearly if we remove your D. Okay, if we remove your D instead of V, so it will be looking like this. Okay, now if without B over here in this particular network, without this B, okay, there is no path vertex. Okay, there is no path vertex between your this. Without that H and this segment. Sorry, without this B, okay, there is no path to the E and C over there. Okay, and the many other. Okay. Hence, it is a disconnected graph, okay, with cut vertices as your D or E. Okay, now, so similarly, in both the cases, okay, in both the terminology of what I said, okay, your D and E is your cut vertices, where this on removing that vertex, the entire segment is deleted. Okay, the connected graph means a graph was like this. Okay, a graph was like this. This is our cut vertices. Either we, if we remove D, this is a resultant. If we so if we okay, if we remove E cut vertices, then this will be the resultant. So this is your two segment. Okay, this is a two segment. Okay, now and the cut edge, in cut edge there is nothing that the path I was talking about, the path. So the path has been removed. Okay, this was your path. Okay, D and E. So this entire path is removed. Okay, where A, B, C, D, E, F, G, H. Okay, let me draw nicely. But to be in a hurry, we have a lot of time. Okay, so this DE was the okay, on removing this particular segment only, okay, we'll get two individual Okay, will give a 2. So this is your cut edge. Okay, the line between C is your cut edge. Okay. So where were we? Okay. So we were talking about your cut set. Okay. The two things was okay. That is your cut set of a graph. This is the motto what we used to understand this. Okay. Now, so let's assume similar way. Okay, we assume any network okay as a G. Okay, entirely network as a G, which has a function of your V and E or only E. Okay, the edges. Okay, the based on the edges. Okay, okay, is to be a connected graph. It is an entirely if a G is your connected graph. Let's G is your connected graph. Okay, now so it has a subset. Okay, okay, if a subset of now of E okay is called a cut set of a graph if deletion of the edge E dash from G makes a G a disconnected. Means if it is a connected graph, okay, it is a summation of some E F. Okay, this is a function of this particular connected graph. Okay, now if we make a subset, okay, subset like E dash, okay, of E, okay, then this subset E dash of E, okay, is called a cut set of a G. Okay, on deletion of all the edges of E dash, means all the edges which is related to this particular part is deleted, then your G would be making as a disconnected graph. Okay, so if deleting a certain number of uh, edges from a graph okay makes it disconnected, then those deleted edges are called the cut set of a graph. I will tell you in a clear manner, okay, that will be make you more understandable, okay, by showing with the example. Okay, now this is your one graph. Okay, this is your one graph. So let's name them E1, E2, E3, E4, E5, E6, E7, E8, and this is your none. Okay, so this is your graph. It's a connected graph, right? And are connected in this. Now, if okay, this is your connected graph, and a cut set, okay, so, sorry, subset, okay, or the cut set is being provided. So let E1, that is your cut set, okay, of the graph is being given. So cut set of a graph is your E1, E3, E5, and E8. Okay, now so after removing this cut set, okay, this cut set, the entire graph would appear as, and it will be called as a disconnected graph.